your Unit 5 packet. Let's check over your answers to this problem that you were asked to complete for today. And then we're going to finish it up. And your homework for tomorrow's pages 27 and 28. 4 questions. That's it. All right. So first thing, you should have made your sketch of this projectile being shot into the air at a 30.0 degree angle. So here is my sketch where I show the dx, the dy, the vi is 100 meters per second. The angle is 30.0 degrees. We have our time t here where it lands. The first thing you should have done is redrawn that to show the right triangle, where we've got our right triangle with the VIX to the right, the VIY going up. The VI is the hypotenuse at 100 meters per second, and the angle theta, which is 30.0 degrees. Now you got to break it up and find the VIX and the VIY using the equations we checked off on page 6 on Thursday. To get the VI in the x direction, you should have written the equation AX is A cosine theta. Which means you should have done 100 meters per second times the cosine of 30.0 degrees to give you 86.6 meters per second for VI in the x direction. To get VI in the y direction, you should have used the equation AY is A sine of theta. So VIY is 100 meters per second times the sine of 30.0 degrees, giving you 50.0 meters per second with the 3 sig figs. Now you make your chart, and your chart should look like this, where A in the x direction is 0 meter per second squared. In the y direction, it is negative 9.81 meter per second squared. VI in the x direction is 86.6 meters per second. In the y, it is positive 50.0 meters per second. The D's are both question marks. The T's are both question marks. And the VF at the top is 86.6 meters per second in the x, and in the y, it is 0 meters per second. In part A, I want the vertical displacement, the height. In part B, I want the time, which we'll use the y direction to get. And in part C, I want the range, the dx. We're going to do part B first. We always get the time first. So to do this in the y direction, we should have chosen the equation VF is VI plus AT. So T is VF minus VI over A. You're now going to plug in. The time to get up to the top is that 0 meter per second velocity minus the positive 50.0 meter per second velocity over negative 9.81 meter per second squared. So your time up was 5.10 seconds. Now, they want the whole time. So what do you do to that answer? Double it. Gives you 10.2 seconds for the total time. Now, you're going to do part C next. Find the range, dx, using d is VIT plus half AT squared. In the x direction, the A is 0. So you're just doing 86.6 meters per second times the total time of 10.2 seconds to give you 883 meters. Now, there are 3 different ways you can find the dy. I will show you all 3. The first way you can get it is by using V bar is D over T. And this is in the Y direction. What is the average of 50 and 0? You got a 0 on one test and a 50 on another. What's your average going to be? 25. 0 plus 50 is 50 divided by 2. 25. To get that D, I would do the V bar times the T, 25.0 meters per second times the 5.10 seconds. Just the time up, because the height is at the half time. So 128 meters if you did it that way. Another way to do it is using D as VIT plus half AT squared. So you would be plugging in 50.0 meters per second times 5.10 seconds plus 1/2 of negative 9.81 meter per second squared times 5.10 seconds, that amount gets squared. If you do it that way, you get 127 meters. The third way you could have done it was using VF squared is VI squared plus 2AD. So D is VF squared minus VI squared over 2A. The VF squared is 0 at the top. So you would have done negative of the positive 50.0 meters per second squared over the quantity 2 times negative 9.81 meter per second squared, giving you 127 meters if you did it that way. Yes, Mark?
How come there's that many ways for the final velocity? I mean, how come there's so many ways for that one, but not the other?
Because now you know 4 things. If you only know 3, there's one way to do it. If you know 4 things, there are multiple ways it could be done. All right, let's go on then to the next page, and we'll finish this up. So we have pages 24 and 25 to complete now, and I'm not going around the room, but I'm just going to randomly call people, so make sure you're paying attention. All right, question 4 says that we have a teacher using this apparatus shown below to demonstrate some of the principles of projectile motion. We have a launching mechanism, which is mounted on this trolley or the cart, and it is firing a ball directly upwards with an initial velocity of 3.9 meters per second. In part A, I want you to calculate the height that the ball rises to above the launching mechanism. Then in part B, I want you to calculate the time for the ball to rise to its highest point. Then in part C, if I push the trolley so it travels at a steady speed of 1.1 meters per second, when it gets to point A, the mechanism fires the ball vertically with an initial speed of 3.9 meters per second. Now I want you to find the distance traveled by the cart before it's caught, before the ball is caught. And we are not going to do part D. So if I were to make a sketch of this, here is the cart traveling to the right. It gets to this point, and that ball will get launched upward at 3.9 meters per second, while the cart is moving to the right at 1.1 meters per second. This ball will go up and out, landing here. Of course, that horizontal distance is the D in the X. The time to get there is T. The vertical height it goes to here is dy, and that gives us our time going up. Now notice I've already given you the components of the velocity. This 1.1 meters per second is which component? X or Y? X. That is your VI in the X direction. What is the 3.9 meters per second? That's the Y component. So that is VI in the Y. Let me go ahead and make my chart. What do we know about each direction? Remember, the first row are your accelerations. In the X direction, Jalila, what is my acceleration always?
0 meters per second.
Correct. Jackson, can you tell me what it is in the Y always? Good. The next thing we're going to put are our VIs. Shane, what is the VI in the X direction for this question? Good. And what is it in the Y direction, Logan?
Yeah.
No. Arne, what is the VI in the Y direction for this question? And it is positive because we have an upward pointing arrow here for the VIY. If it's 0, it's never going to go up. It's only going to go down. Now, let's do our VFs, and this is at the top. What is the final velocity in the X direction at the top, Jacob? That's right. It's not going to change its speed. How about in the Y direction, Mia, at the top? What is the velocity?
0.
That is correct. Now, we always add our D's and our T's here. In this case, I don't know any of those. These are all question marks. Let's now go to part A. What am I asking you to find in part A? Nate, can you tell me? The D in the Y direction, which is the height. Let's look at part B. What am I looking for in part B? Alan? Which time? The time for the ball to rise to its highest point. What do we call that? The time up. And in part C, what am I asking you to find? Bryce? I'm not going to write D-I-S-T-A-N-C-E. What should I write? D what? I've got two D's on my picture. The D and the X. Which part of this do you think I should do first? Yep, part B. Now, looking at your givens, which direction should we be using to help us get that time? The X or the Y? The Y. Because we don't see a change in our velocity in the X, we're not going to be able to get the time otherwise. So we have to use the Y direction to do this. That means you have your A, your VI, and your VF. You're looking for the T. Josiah, can you tell me what equation we should use if I have the A, the VI, and the VF, please? I do not have D, so I cannot use that. I have A, VI, and VF. I'm looking for T. VF equals VI plus AT. So now we got to move it around to solve it for T, which means that the time equation would be what? Eric, can you tell me? Why is that? Yeah, and I'm going to show that here. So VF minus VI over A, where that VF is 0. All right, so now we're going to do our substitution with units. So the time would be negative of positive 3.9 meters per second all over negative 9.81 meter per second squared. And this is just going to give you the time going up, which is what they asked for. A minute to solve it. Dan, can you tell me what you got? Correct. That is our time going up. Now, let's figure out what D in the X direction is. So, in order to do this with the time going up, in my chart, I don't put the time going up. I have to put the total time. So let's just show what that is here. What is the total time it's going to spend in the air? What do you have to do to get the total time? Lila, can you tell me? That's right. So what does that mean the total time is, Nate? Good. Okay, I'm not going to box it in. I'm just going to put it in my chart. The total time is 0.80 seconds. Now we're going to get the range, the D in the X direction, this unknown arrow or question mark right here. Hudson, can you give me an equation I can use in the X direction to get the D? Now we could, but that won't get you the answer because notice that D in that equation is multiplied by A. And look at what A is in the X direction. It's 0. So that won't enable you to get the D because the A is 0. There's another one that's already solved for D. That's the one I would select. And since A in the X direction is 0, that is going to drop out. So we're just doing D is VI times T. So when I substitute in, I'm doing this in the X direction. My X velocity, the VI is 1.1 meters per second. And the time to get all the way over here is the total time of 0.80 seconds. Si Cheng, can you tell me what you got for that horizontal distance, please? That is correct. I'm going to take that value and I'm going to put that in my chart. Now we're going to figure out what the dy is, which occurs here. Notice the time that we have to use to get there. We use the time going up, not the total. I've got an A, I have a VI, I have a VF, and I do have a T. What equation would anyone want to use for this to get the D? Josh, I'll let you pick. What equation would you like to use to get D? I've got 4 variables, which means there are several ways you can get it. Sure, we can do that. Nothing drops out because the only thing that is 0 in the y direction is the final velocity at the top. VF is not in that equation, so nothing drops out. We're now going to do our substitution with units. So that means this distance is positive 3.9 meters per second times the time. Now, what time am I going to plug in? How much time does it spend going from the ground up to the highest point? It's even labeled there, the time up. So yes, we're going to use the 0.40 seconds, not the 0.80 seconds. If you do it with 0.8, guess what your answer is going to be? 0. No, you're going to get a 0 displacement, which means it started on the ground and landed on the ground. It doesn't tell you how high up it goes because of the total time it's back on the ground. No displacement. Plus 1/2 of negative 9.81 meter per second squared times the 0.40 seconds, which we need to square. All right, let's solve that for the height. Brody, can you tell me what you get for that height? That is correct, 0.78 meters for the height. Any questions on number 4? All right, let's do number 5. And number 5, we're going to cross out D and E. Those cannot be done with the math that we have in this class. So notice in this problem, we have a stunt car driver using a ramp, as shown below, to jump over a parked bus. And the horizontal and vertical components of the car's velocity at takeoff are shown here. This is the VI in the X direction, and that is the VI in the Y direction. Now, what I'm going to do, yes. Where's yours? You're going to have to get another one or check lost and found. Come on up. These are the components of the velocity. When I write m times s to the -1 power, that's the same as meters per second. Okay? I'm going to start by redrawing that here. Here is the VIX. Here is the VIY. That hypotenuse is VI, and there is theta. I am told this value is 39 meters per second, and I am told that value is 6.9 meters per second. Let's look at what part A is asking you for. Part A says, what's the speed? What does that mean I'm asking you for? If I say, what is the speed? What does that mean I want to know? Marnay, any idea? Nope. When I say what is the speed, what variable on this picture am I looking for, Bryce? VI. The unknown is VI. In part B, it says, what is the angle of the takeoff ramp? What does that mean I'm looking for in part B? Theta, that's right. Part C says, how much time does it take for the car to reach the highest point? What does that mean we are looking for in part C? The time up. I heard you say that, Colin. Thank you. The time up. T up. We're not going to make our chart yet. Let's get the VI and the theta first. How can I find VI on that picture? What equation from our reference table can we write? Any ideas what equation we can write? So what equation is that, Eric? That is correct. Don't forget, that is on your reference table. Turn back to page 5. And here it is. We even checked it off at one point. A squared plus B squared equals C squared. It is there. We can use it. That's what we're going to do. That means when we do our substitution with units that we have 39 meters per second, which must get squared, plus 6.9 meters per second, which must get squared, to equal the VI that we're looking for, which is squared. Let's now solve that for VI. Nate, do you have it? Excellent. That is 40 meters per second. Now, how are we going to get theta? We need an equation that we can use to help us get theta. Who thinks they have it? Oh, we did this back in unit 2. Right. So theta equals the inverse tangent of what? Very good. The opposite over the adjacent. So let's go ahead and do our substitution with units. Which side is opposite that angle? The 6.9 meters per second. The one that's next to it, adjacent, is 39 meters per second. We can see those meters per second will cancel. So now you're going to solve it, getting the angle to the nearest degree. When I say nearest degree, that means the digit in the ones place must be significant, and that's where you end it. Shane, can you tell me what you got? And what units go on this? Degrees. 10-point degrees. Nearest degree is 10-point degrees. Okay, now part C wants the time up. In order to do that, we have to make our Givens chart. What do we know about, the X and the Y directions? So let's start with A. In the X direction, Jackson, what is A? meters per second squared. Good. In the y direction, Josiah, what is A? Good. Let's now do our VIs. In the x direction, Hudson, what is our VI? Good. And in the y direction, Dan, the VI is? And what is its direction? Because it has to be a velocity here. Positive. We have to put the positive on this because we have a change in the direction of things. We need to show that. Let's talk about the VF, which is at the top. What is the VF in the X direction? Nikki, can you tell me? Correct. What is it in the Y direction? Josh, what is it in the Y direction? Now, we have always put our D and our T's here. I don't know these. These are not given to me. But I am looking for my time going up. When I look at this, I have equal amounts of information in both directions. But this is less useful because I don't see a change in these values. Which direction, therefore, should I be using to help me get the time up? The X or the Y? The Y. What equation can we use to help us get that time going up? Logan? Good. Now we're going to move it around to solve it for T. So that is VF minus VI over A, where that VF at the top is 0. So the time would be negative of positive 6.9 meters per second over negative 9.81 meter per second squared. So when we solve that, how much time is it spending going up? Mariah, do you have it? That is correct. And that's it. We can't do any more than that because if you look at this, this would have been the dx that they were looking for, and the dy would have been all the way up. This would have been the time up, and this would have been the total time. Is this parabola that you see here symmetric around the high point? Is it symmetric around the highest point? No, because the parabola is starting here. So that means we would not have been able to solve this for the rest of what they asked for because it is not symmetric around the highest point. Okay, that's why I crossed out D and E. That's all we can do. All right, that is it because I did question 6 and 7 on the next page. So I would like you now to use the rest of your class time. You have 11 minutes to work on page 27 and 28 for tomorrow. Tomorrow's quiz is a show work quiz. You will get to use those 2 pages in your packet to help you with tomorrow's quiz. Okay? Yeah. Just leave the door a little bit open for you, okay? So you can get back in. That, by the way, finishes the unit. So tomorrow